Mute, share screen, silence those people so they don't irritate each other. All right, and they will presumably eventually notice the Zoom is back on. And again, here they come. All right. So I'll wait for this to get up to maybe 10 when I think they're mostly here. All right, I think I'm going to settle for 8. All right, so I left up here for you people remote. This is the glorious Pew Pew map from Norse, which shows cyber attacks all over the globe and gets people very excited. And the problem with this is absolutely nobody knows what this data is and what they're measuring and whether it's accurate or anything. And it's a perfect example of security lacking metrics to where you no longer know what it means. And so this is what the problem with most vulnerability scores. People look at the number and they think it means something, and then when on closer examination, there is no particular reason to believe that number and no particular reason to trust it, and you end up unsure whether you've actually benefited yourself or not based on these scores. Anyway, so we got down to an example here of Greenbone reporting a bunch of things. Some are red or some are yellow, and that is somebody's estimate of which one's more dangerous, and you need to apply human intelligence to the real business situation to decide which ones of those things have to be fixed and which ones don't have to be fixed. All right, so you can do ping sweeps to sweep a whole bunch of addresses to see if something's there. Of course, the problem is machines that are turned off or disconnected won't answer, and Windows machines won't answer anymore, and other machines won't answer if firewall's blocking it. So a ping sweep is not an extremely effective way of reconning a network. ARP scans are much better, but you can only do an ARP scan on the local network. So if you're outside a company 2 or 3 hops away, your ARPs will never get there. And so the only thing you can do is target things by IP address. So reconnoitering a company from off premises is a more uncertain and difficult task. There are tools to try to ping or send other packets faster. Nmap is kind of slow. Hping is one of the command line utilities that can send a lot of different types of packets to the target. It just has a long list of choices here. Hping is another one. So it'll tell you this is alive, that's unreachable. I think NetDiscovery is more fun, but that's only ARP. Hping is another one that has many, many options, many ways to alter the traffic. So there's a time when I was a beginner and I used these tools. I was stuck with Nmap switches and Hping and Fping. And then I come across an IPv6 vulnerability that brought down Windows machines, and I contacted Microsoft Security Division, which is very responsive these days. Most companies I contact about vulnerabilities just go, blah, 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 blah. I get nothing out of them. Microsoft used to do that, and they wised up. And if you have a security problem at Microsoft, you can reach people that will talk to you intelligently quite quickly, because they have gotten used to the fact that there really are security reports coming in that matter, and they really better listen to you if you have something to say about it. So within 3 days, I got a clear answer from them. They said, we're not going to fix it. But they said, by the way, have you tried Scapy? And I said, no. And they said, you got to check it out, because then you'll throw all these tools away. Scapy is a Python library, and it is so much better than all these tools that I never use these complicated tools anymore. Because, I mean, if you're stuck using a program somebody else wrote, you're stuck with the options they gave you. So then you'd find another program like Fping or Hping that has more options and feel like you've taken a step up. But when you get tired of doing what other people tell you to do, you just write your own tools. And it turns out to be so easy to write scanners in Python that you'll never go back to these crappy things again. Anyway, one issue is broadcast addresses. That's good, clean fun. And let's see if that works. That actually used to work on the City College network, and it might. So if I do ifconfig, EN0, that's my wireless adapter. Okay, I have this address, but more to the point, I have this net mask. Now, if you've taken your Cisco subnetting, you may recognize that this is a supernetted network halfway between Class B and Class C. This is 255.255.240.0. Anyway, they give me the broadcast address right there. That is the broadcast address. You can send traffic to that broadcast address. I don't think I can ping it directly. I think I'm going to need to put in some switches. Oh, no, there we go. Neat, it's working. This is awesome. So if I send one ping to the broadcast address, the switches and routers send it to every device, and they answer. And these are all the Macs being used by teachers. I'm on the instruction network, The student side, I think, is now in isolation mode. So you'll just get one device, just you and the router. But the teacher's side still doesn't have it. So there we go. These are all the other teachers' machines. So this would be the first step to hack into everybody's machine. Now I get their IP address. That Net Discoverer was finding them earlier. And once I found their IP address or their MAC address so I can send data to them, then I can follow with a port scan, find an open port, attack it, and go to town. So this is the one other thing about this. This is an alternative to a port scan where you scan every address. Just scan the broadcast address, and with one packet, I get everything. Now, Windows machines won't answer, and networks that are configured in isolation mode will not forward the broadcast, so this is not as useful as it used to be. But in the early days, you could do this from off campus. You could send it to the City College broadcast address from another network, and the routers on the internet would forward it, and they would forward all the replies back to you. So that led to the Smurf attack, which is here. If I wanted to bring down a server and I had like a 56K line, I can only send 56 kilobits per second at the server, and that's not enough. So instead of attacking the target directly, I send pings to a broadcast address at a big network like this college with them as the from address. So I send one ping and 1,000 replies go to the target. Now they get hit by 1,000 times as many packets, and they get attacked by somebody that's not me. The college is now taking them down. So they might write a nasty letter to the college or sue the college or something, or block the college in their firewall, and I'm the real attacker over here laughing, not getting caught. That's a bandwidth amplification attack, and there's a lot of them. And the Smurf attack was the first bandwidth amplification attack. And to stop this one, they reconfigured the routers on the backbone of the internet to no longer forward broadcast packets. So if you try to ping a broadcast address from off campus, it will not reach there and the replies won't come back to you. You will not be able to do this anymore. You can only do it on a local area network like I just did here. So that makes, I could still use this to perform a denial of service attack against other people. I could take down another teacher's laptop right now by sending a flood, and all those replies would go to them. So we're vulnerable to that extent, but only on the LAN, so at least you have a lower suspect pool. Yep, there we are. Used to work here and still works on the teacher's network. All right, so that's, like I say, packet crafting is when you want to make a special packet for some reason, like a new attack came out and you want to test it, you want to test your firewall, you want to send all sorts of goofy packets to it and see if it really blocks them all, things like that. Then Nmap doesn't have enough options, so you might try Fping and Hping that have more options, but when you get tired of messing around, you just make your own script. You just write a program to do it. It's not that hard. We do a lot of it in the class after this one. You can write bash shell scripts, which are just basically a recording of the commands you would have typed at the command line. So that's the simplest way to make a script. And you start these things with the shebang line, pound bang, exclamation point, and then a path like bin sh will start the shell. Then you have commands here. You can have these loops, like, well, count less than 253, do this, and then done. That's one possible way to do it, loops in bash. You can take bash shell scripting classes here, and it's a useful talent, but bash is really pretty limited as a command to program in. Python is a lot better, and I have several projects here where you use Scapy. If you just import Scapy, it is very easy to make simple projects, so you can even use Python in immediate mode like I did here without even writing a script. So you just start Scapy here in Corley, and it gives it to you. Now you can define an IP object, define the destination, define a UDP object, destination port, and then you can just send data and it'll go to this listener, which is just netcat listening on UDP. So you can make a little chat client, and you've been doing this in the projects that you make your own TCP handshake and so on. With Scapy, it is very easy to make your own packets to do anything you want. So that's why Python is the programming language of choice for beginning hackers. If you know more languages, that's great. But if you don't know anything, learn Python at least. Because with Python, you can do a lot. It is the sweet spot for most people between ease of use and power. Anyway, and this book is one I used in the class after this one. Violent Python is a book that teaches you how to use very simple programs to do common hacking attacks. So you can get it. You don't have to be much of a genius programmer. You don't have to be very precise. You don't have to be very thoughtful. You can write sloppy code that will still hack into things because we're a breaker. You don't really care if it's got mistakes. You just fix it until it works. It's not like you're actually making a product that you're going to sell, and then you're going to have to be tech support and fix all the things that are wrong with it. You're just making something for you to use once. So it's really more like throwing a brick through a window than it is like building a car and selling it. Anyway, so I got a few cahoots about this stuff. All right. Let's bring them up. We can dispense with the pew pew map. And here's the cahoots. All right. There we go. 389, 585. All right. Wait a few more seconds. All right. 5 more seconds. I'll wait a little longer, then they're still coming in. Okay. All right. 5 more. Oh, I think we got everybody. Okay. 4 questions. So, which one of these is a port scanner, not a vuln scanner? That's Nmap. Nmap does have some scripts that do some vulnerability tests, but it's not at all as thorough as something like Nessus that really finds their vulns. All right. Which one of these is a Python library? Okay, that's Scapy. All right. Where's the commercial vuln scanner? All right, that's Nessus. Okay. And which one will give you the most flexibility in making any kind of packet you want? Okay, that's of course Scapy. If you write your own program, the sky's the limit. All right. So, question mark, and Kaji, and Batchies. So I know who Cam is, but the rest of these people are going to have to tell me who they are to get their points. You're Batchies, okay. What's your name?
That's my last name.
That's your last name. Good. Okay, good. That'll do then. All right. And Cam, we know. Yeah. Okay, what's your name? Shaylee. A question mark. Say. Lee. All right. Are any other winners? Perhaps they're online. Well, you can email in your name. If you winners want to send me a chat message now, that would do. Looks like that's not happening. Ah, here comes one. Good. So, Kaji is named Kaji. Wait, Kaji is your real name, perhaps? Okay. Ah, Blake. Okay. All right. There's probably only one Blake. Good. Any others? All right. Well, I'm going to stop the recording, and you can email in your identities if you want to claim your points later. All right.